The discovery began with something that almost shouldn't exist: the faint, ancient glow of a supernova that detonated more than 13 billion years ago, at a time when the universe was barely 5% of the age it is today. Scientists realized they weren't just looking at another distant explosion. They were staring back into a period when the first massive stars were still forming, a chapter of cosmic history we were never meant to witness in such detail. What made this even more unreal was how incredibly rare it was. In the last half-century, astronomers have detected only a handful of gamma-ray bursts from the universe's first billion years, and this one didn't just join that tiny list. It pushed right past the edge of what we thought we could observe. It wasn't just an old supernova, it was a message from the universe's earliest moments, traveling across time to reach us now. Everything kicked off when a sudden blast of high-energy radiation struck one of our satellites, a signal so sharp and so distant that it immediately raised alarms among astronomers. On March 14th, the French-Chinese SVOM mission caught the first flash, a powerful gamma-ray burst, later labeled GRB 250314A, the kind of event that only happens when a massive star collapses in the final seconds of its life. Less than 2 hours later, NASA's Swift Observatory picked up the same burst in X-rays, tightening the coordinates and confirming that whatever exploded was unimaginably far away. GRBs from this era of the universe are almost never seen, and the sheer faintness of this one suggested something extraordinary. It may have come from a time when galaxies were just forming, and the first generations of stars were burning themselves out. Scientists didn't know it yet, but this single flash would lead them to one of the oldest stellar deaths ever captured. Once word spread about the burst, telescopes around the world jumped into action, each one racing to catch whatever faint traces were still drifting through space. About 11 hours after Swift locked onto the signal, the Nordic Optical Telescope finally spotted the fragile afterglow, a dim shimmer created as the star's expelled material slammed into the gas surrounding it. It wasn't much, but it was enough to confirm that this explosion was unbelievably far away. Then the Very Large Telescope took over, measuring a redshift of 7.3, a staggering number that placed the event 13 billion years in the past. At that distance, the expansion of the universe stretches and slows everything we see, making the supernova appear to brighten over months instead of days. It was like watching an ancient disaster play out in slow motion, a final breath from a star that died long before our planet even formed. With the redshift confirmed, astronomers knew they were staring at something that demanded the most powerful eyes humans have ever built. Andrew Levan and his team quickly pushed for emergency observing time on the James Webb Space Telescope, a privilege reserved only for discoveries that can't wait. And when July 1st arrived, Webb delivered exactly what they needed. In a patch of sky barely brighter than static, its sensors picked up the unmistakable glow of a supernova, the collapsing core of a massive star that lived and died in the universe's earliest chapter. Even more astonishing, Webb managed to catch the faint outline of the host galaxy itself, a tiny smear of light stretched across only a few pixels. Yet those pixels told an incredible story. Despite existing so shortly after the Big Bang, this distant galaxy wasn't wildly different from the ones we see today. Webb had confirmed not just the explosion, but the environment it came from, peering deeper into cosmic history than any telescope before it. What surprised astronomers next was how strangely familiar this ancient explosion looked. Even though this supernova erupted in the universe still in its infancy, with far fewer heavy elements and far simpler galaxies, its spectral fingerprint resembled the massive star explosions we see in the modern cosmos. That similarity raised an unexpected question. How could a star born so close to the dawn of time behave so much like the ones forming billions of years later? Scientists suspect the answer lies in the details hidden within the spectrum, tiny clues shaped by the scarcity of heavy elements in that early era. Those subtle differences could reveal how the first generations of stars lived, evolved, and died, and whether the early universe produced more powerful or more unstable giants than the ones we're familiar with today. But even with these insights, there was still one final revelation waiting, one that would push this discovery into the record books. When the data was finally compared to every cosmic explosion ever recorded, the scale of this discovery became impossible to ignore. This supernova didn't just break the previous distance record, it obliterated it. The last oldest known supernova exploded around 1.8 billion years after the Big Bang, a staggering distance on its own. But this one came from a time more than a billion years earlier, deep inside the universe's first billion years, when stars were just beginning to form in earnest. Only a few gamma-ray bursts have ever been traced back that far, and nearly all of them lack a confirmed supernova. This event, captured across multiple observatories and sealed by the James Webb Space Telescope, proved that we can now witness stellar deaths from an age we once thought was completely unreachable. And if a star this old can be found, astronomers now believe there may be countless others hiding just beyond the edge of what we've seen so far. This discovery doesn't just push astronomy forward. It forces us to rethink how quickly the young universe came to life. Seeing a star explode at such an early moment suggests that massive stars were forming, dying, and reshaping their galaxies far sooner than anyone expected. And now that the James Webb Space Telescope has proven it can catch these ancient signals, the boundaries of what we can observe are shifting almost by the week. Every new detection pulls the curtain back a little further, revealing a universe that was far more dynamic and far more chaotic than scientists once believed. And if we can witness the death of a star from nearly the beginning of time, it leaves one haunting question hanging in the air. Just how much deeper into our cosmic past are we about to see?